Oliver the cat, who was in the previous episode, has decided he doesn't really enjoy this section at all, so he hasn't returned. He's bunking class. And what we're going to do now is we're going to go on to another method of simultaneous equations called substitution. So the elimination method we did in the last two episodes is very helpful, but it's used when you're working with two linear equations, and as I explained before, that's when you're trying to find the point of intersection of two straight line graphs on a Cartesian plane. So just to give you a little bit of insight into this method that we're going to use now, these are both linear equations because they've got an x term, a y term, and a constant. Both of them have got that, so they are linear equations. They can be rewritten in the general form of y equals mx plus c. But let's just think ahead a little bit. We haven't got there yet. But if we were trying to find the points of intersection, say for instance between a parabola and a straight line graph, first of all you'll notice that here we've got 2 points of intersection occurring. Because of the shape of the parabola, we've got the straight line graph and the parabola intersecting there and also intersecting there. So we would get 2 points of intersection, and we would be dealing with a linear equation and a quadratic equation at the same time, which would mean that we couldn't actually use the elimination method. But we're not at that situation yet. We're working with linear. However, with linear equations, you can also use this method, and it's a very good idea to become very familiar with it, because if you know it well, then once you get onto this situation, you'll have no trouble adjusting it all. So let's see what the name says. It says substitution method. So we're going to substitute something in the place of something else. So what you do is you look at your two equations, and let's again start off by numbering them, number 1 and number 2. You look at your two equations and you see if either of those equations have got either an x or a y that only has a coefficient of 1. So in the first equation, no, we've got a 3 and a 2. In the second equation, y has got a coefficient of 3, but x has got a coefficient of -1. So I'm going to use that equation, and I'm going to tell the reader that I'm working with equation 2, and I'm going to manipulate equation 2 a little bit so that I get x as the subject of the formula. In other words, I want to get x on its own on one side. So if you think of leaving this here on the left-hand side and that, and taking this across, it's going to become, from -x, it's going to become +x. So that's exactly what I'm going to do. So 3y minus 5 is going to be equal to +x. But I feel like swapping the two sides over just so it's in a more conventional form. So remember, that does mean the same as what we said, because the x is going across as positive, and now I've just written the left-hand side and the right-hand side the other way around, so that I've got x, the subject of the formula. And as soon as I've manipulated an equation anyway, I need to give it a new name, so that later on, if I'm speaking about this equation, I call it 3. If I'm speaking about that equation, I call it 1, etc. So because x is the subject to the formula, I'm now going to substitute this equation into the equation that I haven't manipulated. So be very careful about that. If you manipulated equation 2 to become equation 3, then you need to substitute this into the one that you didn't manipulate. So now, wherever I see an x in equation 1, I'm going to write this instead of the x. So 3x means 3 times x. So now I need to say 3 times and this new value of x that I've created. There are no more x's in the equation, so that's easy. I just copy the rest down. And now you'll notice that I've only got y's in my equation. So I'm going to multiply. I'm now back to a normal linear equation. I'm going to multiply out the brackets and then start getting the y's on the one side and the constants on the other. So I've got 9y, 3 times -5, every Everything else, I'm going to take a shortcut and quickly take that across straight away. So it crosses the equal sign, it becomes 29. 9y plus 2y is equal to 11y. The minus 15 is going to go across and become positive 15. So I've got 29 plus 15. All right, let's clean up the right-hand side. So 29 plus 15 is going to give me 44. Divide by 11, divide by 11, and y is equal to 4. In any simultaneous equation, no matter what method you're using, remember when you found the one variable, you have not finished, because simultaneous equation means using two equations to find two variables at the same time, which is giving you points of intersection. So now I need to substitute that back into one of these three. Now, with the substitution method, when you found this first variable, you'll see that the easiest way to find the other variable is to substitute it back into your manipulated equation. So I'm going to say substitute y equals to 4 into that equation, which will mean, and I'm going to go straight into the answer, it will mean that x is equal to 3 times the value of y is 4 minus 5. 3 4s are 12. 12 minus 5 is 7. So I've got an x value, a y value, therefore my ordered pair is 7, 4. In our next episode, we're going to look at a rather complex looking pair of simultaneous equations, which are going to involve fractions, which means we're going to have denominators, and those are the kinds of things that examiners like to include to see who has really understood the section. So look out for that video as well, please. The easiest way to do that is to subscribe, and then you'll see it straight away.